Hello, good evening. We're here at our Big Things meetup today. We'll be presenting now a lecture by AppsFlyer. Morri from AppsFlyer will be presenting their usage of Spark over Mesos and all of their lessons learned. And you're welcome to start the lecture. Thanks.
Thank you. We'll see. How's that? Is it, yeah, it's on. We did it to miss the screen.
Just try to reconnect the cable.
Okay. Just take it out and plug it in.
Yeah, exactly. And if not, I will press it again.
Okay, first I'm curious, who all is using Spark here? Okay, great. How about Mesos? And how about Spark on Mesos? Okay, great. So there'll be something for some people, and I think that's really helpful. So the plan is we're an attribution and analytics company in mobile advertising, and so I'm going to explain what that means to give you a little framework to understand in the analytics part, which you probably will understand. And then I'll give you a little vignette about one of our main analytic projects, the retention report. And then I'll dive into, okay, is that better? Then I'll dive into what we've learned using Spark on Mesos and some of the challenges and some of the nice parts. And just stop me anytime you want to ask a question or. Okay, so what we do is we attribute installs from cell phones back to media sources that ran the advertising. The way we typically do that is we catch the initial click from the cell phone, and then we redirect that to the appropriate store. But when we redirect it, we add a little tag to it. So then once we see the install, we can match that back to the original click and assign the mobile attribution correctly. And this is, but we have to do it across a suite of different media sources, and we currently use last click attribution. So whoever was the last click will get the attribution. We do all this attribution in real time. So as the clicks and the installs are coming in, we attribute them in real time. So what we have, is a suite of web handlers that are catching the clicks and the installs, and then moving them onto both Kafka queues and RabbitMQ for we use RabbitMQ for a faster traffic, so that we can very quickly make the attribution. And then we also put the attribution onto Kafka so that it can flow throughout the rest of our system, and we can move it into databases that serve the dashboard. And eventually, at the end of the Kafka queue, we use a service called Secor from, it's an open source project from Pinterest that just dumps the data onto S3. And that's where it finally comes to rest. It's important that we do the attribution in real time because after the cell phone launches its first install, it has the ability to ask us what is the attribution, and it does this so that it can bring up an appropriate page to the user. So if the user clicked on an advertisement for hotels in New York, that's the page that'll come up when they launch the app the first time. So it's important that we very quickly make the attribution and have it available to the cell phone. Okay, but most of my work starts after all this is done. Once the data goes on to S3, and then we start to do analytic work with it. One of the most important reports that we produce for all our clients is the retention report. So, and the way this works is this is the number of installs on a particular day. And what we're interested in with the retention report is how long are those installs active. So what you can see here is for one grouping, they had 600 installs, and the next day they only saw 85 of those installs. But for another grouping, they had a similar number, like 500 installs, and the next day they saw 200. And then, out to 2 weeks, you can see that this particular grouping has only 4% of the installs are left and still active, and this grouping, it's like 25% of the installs. And so this is really important for our clients. They want to know what's the quality of the installs, not just the quantity.
And you have an ID of some kind to identify which installs have been uninstalled already?
The uninstall, we don't. The uninstall is a little tricky to track.
Mm-hmm. So how do you know the difference between the actual installs that happened, that occurred, and which retained?
So we watch every launch. So we get about 25 million installs a day, but we're also watching every launch of the app to get close to 5 billion of those launches every day. So if we saw an install and we don't see any launch on a day, then we think that it's probably gone.
Down.
Yeah. And if it comes back again later, that's all right. Like occasionally you'll actually see that the retention goes up, right? Like here it was 30%, here it's 35%. So some of those users came back, they just weren't active for one day. But the general trend is usually down.
It's activity mostly, and not installation and uninstallation, right?
Right, it's activity, but matched back to a particular day and a particular grouping of installs.
So you build some kind of SDK that they integrate in the app?
Yeah, exactly. Good question. So we have an SDK, and when the app launches, our SDK sends us information for every launch. So our first attempt at this report, we just had was a very simple. We just used 2 dimensions: the app ID and the media source. Media source is something like Google AdWords or Facebook, and we used a framework called Cascalog, which is pretty nice. allows you to write logic programming, like Prolog or Datalog style queries, and then it compiles them down into, using Cascading library, it compiles them down to Hadoop MapReduce. So it's a very friendly way to work with the Hadoop framework, and it worked well for maybe 6 months or so. But also our traffic is growing every day. We've been growing exponentially for the past few years. So eventually the report just came to a halt, and we couldn't get it to run anymore. You know, we added more machines, we added more memory. That bought us another week or two, and then the same thing. And also our ability to troubleshoot the Hadoop ecosystem was pretty poor, and we thought it's time for a change, and that we'll re-implement the retention report, but in Spark this time. This was somewhat motivated by a similar report that I had already written, the cohort report, and I wrote that in Spark using the low-level RDD API, which was the only thing, you know, the Spark and the Spark SQL and Shark was still beta at the time. This was nearly a year ago.
You mean it's Spark 1.0?
Yeah, it was something like that, yeah. So I used a wrapper that I like a lot around the Spark API. It's called Sparkling, and it's yeah, it's in Clojure. We write most of our code in Clojure at AppsFlyer, and there's an API that converts the Spark API into pretty much idiomatic Clojure, as you can see here. So this function takes a file, pulls the lines of the file in, and then it searches for the records that are from the Angry Birds cell phone app. It's just a toy example here. And this in Sparkling does the same thing. So we call the text file function to bring in a file as an RDD, and then we parse the JSON and filter it using the same basic construct. The only difference is instead of it being Clojure filter, it's the Spark filter. And at the end, instead of the result being there, you have to collect it because Spark is lazy. And that works great.
And it's not much there, right? Because trying to collect it to the driver could kill you if it's
right. Yeah, that was just an example for this. But normally you would have a
count or something like that first.
Yeah, or save as text file again would be the right thing to do. And that report is actually still running in production. It works pretty well. But for the retention, for the rewrite, Arnon decided to rewrite it in Spark SQL, which at this point is probably like 6 or 7 months ago, was getting much more mature and looked like a pretty good option. But what this really necessitated was a change in our data store, because before, on S3 we had raw Hadoop sequence files that we got from this SECOR process that the Pinterest project that I told you about. And this is just a flat file with a key which came from the Kafka offset and a value which is just the JSON message. And we have those flat files. The only way to search them is to walk through the whole thing and look for the records that you want. And so what we began to use is Parquet, a very nice file format, and it has a schema, and it's stored as a columnar format instead of just being flat records. the columns are stored together. This increases the ability to compress the files and also makes aggregations much less expensive over the files. And you can access pretty much random access to the columns that you want, rather than opening up every JSON, converting it to whatever programming language you use. And so this has been good. Our first attempt at this was, you could say, schema on write. So we took the raw Hadoop sequence files, we figured out which fields we need to do a retention report, and we converted those to Parquet and applied a bit of business logic at the same time. And that worked.
You duplicated the data probably, right?
Yeah, it's a duplication of the data, definitely. Yeah.
You shrinked it down, but you duplicated it.
Yeah, definitely. And we still keep this raw format for
just in case.
Just in case, and it's exactly what the system saw in Kafka, so it's nice to have it still around.
And you can replay the data as well.
Yeah, exactly. It's harder to do that from the Parquet. So once we converted to Parquet files, that generates, the Parquet reads straight into Spark SQL as tables, and then the retention report is simply an SQL query. You know, select the columns you want and join to the other table, and it's very nice. It works super great. So I think we'll probably convert this older cohort report to the same infrastructure. So whereas the original report only had 2 dimensions, it was just the app ID, which you might even not consider a dimension because our clients don't care, you know. And it had just the media source, which is the only client-facing dimension. Now there's 18 dimensions in the report, and it's much richer, and it runs in a similar amount of time, and it runs, which is
by the dimension, you mean the amount of features that you're showing, right?
Exactly. So a dimension might be the campaign, the name of the campaign they ran, whether the install was on Wi-Fi or not. What are some other just other parameters that we track? To do this, we actually run it kind of in 2 phases. And the first is we use a SQL query to, in a daily step, we aggregate all the activity is the day that we're aggregating, and then the cohort day, this is the install day. So what we're doing is we're saying, for all the activity that we saw today, linked back to all the install days across all the dimensions, how many installs do we see again today? So that's like the first step. But then to make it all easier to query and to reduce the data by quite a bit, we do a pivot of this data. So we eliminate this activity day and we fold that into counts for the final retention report, day 0, 1, 2, 3, and so on. And these dimensions again are things like the campaign and whether the install was on Wi-Fi. And then this is what actually goes in to the database. Currently we have it sitting in Redshift. We're not entirely happy with that, and we're looking for another solution.
Performance-wise?
Yeah, it's slow, and it doesn't like to have very many concurrent queries, so it's a pretty poor choice for a user-facing.
And what's the amount of data actually sitting there? Like size-wise, not the amount.
Size-wise,
Probably have retention for several amount of time.
yeah, the retention goes back till the beginning of time, which was May the 4th day. And I don't know in terms of like gigabytes, but it's about 1 billion rows of this data here.
Per day?
Yeah.
The dimensions, it's all the possibilities of all the...
Exactly. All the possibilities. So this campaign...
features?
Yeah, like this campaign with this country, and this campaign with this other country, and all the combinations that are possible. It comes out to about 1 billion rows right now.
Aggregated.
Aggregated and pivoted and aggregated again. I recently tried putting it into a memSQL, and it used, I needed to launch about 2 terabytes of RAM, which would be kind of cost prohibitive, we decided. So we're still looking for a final place to serve the data after we aggregate it.
Cassandra might be a good choice.
Which one?
Cassandra.
Yeah.
Depends on the structure of the data, probably.
Yeah.
All that make it.
Yeah, well, maybe we can talk later.
No problem.
Yeah.
What do you use for pivot?
Also Spark. It's 2 Spark SQL jobs. The first one, we write out the files, basically just CSV columns with these columns, and then the second one we put them in, and then do an aggregation, and then write them back out, and then put them into the database. And I'm simplifying a little bit. The pivot is actually an incremental pivot, so we have the pivot from yesterday, and then we bring in the new data, pivot it, and then do another aggregation. So all of that's just these little steps to make it work well.
How many columns do you have? Do you threshold the day at some point? How does it go?
Let's see, how many columns? Oh, we have 30 days. 30 days. And we have a value for every day.
It's a sliding window of 30 days.
I'll just go back to the picture. It's like, so here in this picture, this first column is the install day, and then the data here are the values for days after the install day, and we go all the way out to 30 days in the report. So total columns, we have 30 days and 18 dimensions and one more, so that number of columns.
Do you check peak hours
We just do days, so a whole.
so you can't measure the time of the day. It's best to.
Yeah, that's something we'd like to do, is support time zones for our users, because some of our clients, a lot of them are in China. They don't really want to see the retention report for we use the GMT time. They don't really care about that day. It's irrelevant, and when there's a lot of installs across the boundary of the GMT, you get kind of a skew in the retention, because it's very easy to get retention if the install happened at 11 p.m. and then the next day, is 1 a.m. UTC time. It's very easy to get a high retention. So if your peak install hour is kind of aligned up there, it's not so good. So we're hoping to fix that. Another problem that we're having is that we did this conversion of Parquet, made a much more accessible data store, but we didn't convert everything. So every week we find a new field that we think we are interested in, and we'd like to be able to query it. So what Arnon is doing is what he calls schema on read. So he's converting the raw JSON over to Parquet, keeping almost all the fields, even things that don't look that interesting. And then, and also don't apply any business logic because that can evolve over time. And then create a shared library that knows how to access the data and apply any business logic to it. So that's why it calls it schema on read. So the schema can kind of change. So that's going to be our latest change.
Usually you do it with Hive. Schema read.
Huh. Okay. Yeah, he's working heavily with UDFs to implement the business logic. Is that what you mean? Yeah. Yeah. We generally use the Spark SQL context, but they have a lot of functionality now in there. So now I'm going to transition to talk a little bit about our use of Mesos. Okay, I think that'll work. And how we got to using Spark on Mesos. It seems that it's not, based on my survey here, it's not so common. I saw two people that were also using Spark on Mesos out of most of the audience using Spark. So
You're using the other frameworks over Mesos, or solely Spark and Mesos? That's it.
Spark, Mesos. We have a few things on Marathon and Chronos.
Probably.
Yeah.
But you're not using a different framework. I don't know, like running Node.js servers or a different kind of database, because this is like the more common usage of Spark over Mesos. Because if not, you don't want to add the complexity of Spark over Mesos, and you just run the standalone cluster. That's I think
most people are using the standalone cluster.
Or the standalone, or if someone is on Amazon, they've heard the EMR.
Right.
Or because of Yarn, they're using distributions or something like it.
Yeah.
So it really depends on the use case of the company.
We started with the standalone cluster. There's these scripts. You can just you launch a cluster. At the time, and maybe it's still true, you can't launch it into a VPC.
You can, I think.
You can
or at
now.
least we've changed, I think.
Okay, you've edited it, and at the time, we were converting to VPC on Amazon, so it didn't really make sense to keep working with that. We also experiment. I'm not sure we're going to do it with putting a lot of our main attribution infrastructure onto Mesos. It makes sense from a utilization standpoint. Anecdotally, Ariel just tried this out. One night he launched something onto this Mesos cluster that he was testing, and the service killed the node, and then the Mesos relaunched it on another node. It killed that node, and it took
snowball effect there.
And that way, it took down the whole cluster. So he felt it wasn't quite ready for. But I don't know. We may go that way in the future. And we like to try new things out that look promising, and so far I think it's been pretty good. So yeah.
What's the advantage of Mesos over standalone?
Oh, at the time, it was easier to launch because the scripts. It wasn't possible to launch the standalone very easily into a VPC. I think that's fixed now, or you can work around it more easily. Also, I was having a lot of stability problems, and we thought Mesos has a long history with Spark. It was created actually as a
Spark was
created to show off the nice features of Mesos. So I thought probably their integration is good. I'm not sure that's actually true, but but it's that was our thinking at the time. And rather than doing yarn, which seemed overly complicated because we don't need HDFS at all. It seemed overly complicated to launch a yarn cluster just to run Spark. So I thought, well, we'll try Mesos. We can get a robust cluster without the Hadoop part of things that we didn't want to deal with anyway. Some of the things that I really like about Mesos, the UI is really nice. You can, for every one of your jobs, you can very quickly go find the error logs. When the job fails, you can just drill down very quickly, go find out what went wrong. You can click on the standard error here, and it brings up just a live update of what's coming out of your job. So that's pretty nice. I'm sure it's also true on EMR, but when we tried to use it, it was difficult.
On EMR, it's just using yarns functionality, so it's almost the same. Okay.
So it was difficult for us to find the logs and figure out what was going wrong on EMR so far.
Ollie?
Yeah.
What's the time frame you're talking about? When have you started Mesos?
When did we started almost a year ago?
Makes sense.
Okay.
EMR wasn't really
Yeah.
at all like it was.
Yeah, actually, that's another point. When we started, it wasn't even an option to use EMR. There was like a blog about a bootstrap that you could run. So we decided, well, we'll try Mesos. Thanks, though. I forgot about that. Another nice thing is the masters, they store all their state in Zookeeper. So you kill a Mesos master and the other one notices and starts right back up. Your jobs continue as if nothing happened. I was really surprised that worked so well. Also, all the nodes, they just, you fire up a node, and once it comes online, it joins the cluster automatically. You kill a node, it leaves automatically. So that part, operations-wise, is really relaxing. And maybe as just a side point, we launch all of our stuff on Spot instances. So having nodes coming up and down a lot is not unheard of. So it's nice that the infrastructure can do it very dynamically. We use Chronos for scheduling. It's all right. It shows you like a list of your jobs, which ones have failed. You can drill into the job and get, what's the command and a little more information. You can click here and run the job manually. It's all right. If you're interested, you can check out this blog post by Kyle Kingsbury. He looks into the problem that Chronos actually likes to stop scheduling your jobs if it has a network partition. So be careful if you use Chronos. Sometimes you'll come in the next day and none of your jobs ran and there's no explanation. It's just Chronos just stopped scheduling. So we have monitoring outside of the main jobs to make sure everything's continuing to run. And we're probably going to try out Aurora to get around those downsides. But we haven't. Does anyone have experience with Aurora? Yeah? Okay. I'm just going to now very quickly, it seems like everyone knows most about Spark, so.
15 minutes.
Okay. Yeah, that'll be great. Spark divides, takes your data and creates an abstraction, the resilient distributed data set. You could think of it just as partitioned data. The default partitioning will be the number of files that you have or some multiple of the number of files. Your job, that's like the overall thing that you're doing as a job. That'll be divided into stages. Each stage will be divided into many tasks. Each task corresponds to one partition of the data. And the stages have a strong separation. They have to go, and then in between stages you have the shuffle, which I'll talk more about. But stages are separated by the shuffle. So in the shuffle, before the shuffle, every machine takes the data and writes it out into buckets based on the partitioning scheme that will exist after the shuffle. And then after the shuffle, all the machines, now each machine is or each task, again, is a partition. They'll go to the machines and ask for the data that belongs in their partition. Here they're using the word bucket. But Spark doesn't want to do anything across this boundary. So everything up here has to finish before you can start the next round. And this has implications for how efficient the cluster can run, which I'll talk about next.
This is the difference between a narrow and a wide operation in Spark. Like the wide and narrow transformation, not an operation.
Okay.
And once you have map filter and things like combined, it does that linearly.
Right.
And once you have a shuffle that you got into, it's a wide transformation, and you need to wait for everything to finish.
Yeah, yeah. So we have some jobs that are map only. Those are nice, like our transformation jobs from raw to Parquet is just read it in, write it out. And in terms of how the Spark interacts with the cluster, there are variations on, there's two modes that I'm going to discuss next, but they're all variations on a theme where the Spark, your program, the Spark context runs in a driver. It talks to the cluster manager, which is Mesos in my case, and asks Mesos for some resources. And then it runs its tasks on those resources. And I'll get more into how it does that. What were some of the things that we've dealt with? I'll go over some of these quickly because there's a nice blog post that Arnon wrote that you can read about. But briefly, for a while, every day at 5 p.m., all our jobs would fail. This stopped when we upgraded from the S3N connector to S3 and started using S3A, which is the next version. Also, there were a ton of timeout exceptions, and the only way to get your jobs to run was to allow a task to fail 20 times, and then we could succeed. Now we run this S3A library from Hadoop 2.7, and things are really good. It's very stable. We don't have any exceptions anymore.
By the way, do you have knowledge why the failures happen?
I don't know.
It's really hard to know the reason.
Yeah. We would watch, and it seems that the AWS was switching their DNS, and somehow this library didn't know how to pick up on the DNS change, and it would say that it couldn't find S3. But it's, your job's running in Amazon. How can you not find S3? That's unreasonable, right? So,
Did you see a 100% CPU usage at those moments? Because there's a problem in the EC2. When nodes hit the top CPU usage, they can resolve DNS.
That could be. But it was every day at 5 p.m., so.
I have to go home.
Yeah, that's what I did some days. Also, there's a really fun bug if you use S3A from Hadoop 2.6. Okay. You'll get millions of partitions in your data. It's because they have some block size set to 0, so you end up with 1 million partitions. Most of them are empty. here I'll just be quick on this. S3, it's very expensive to rename a file in S3, and Spark doesn't know that. It thinks that it's running on HDFS by default, and so it writes its data out to a temporary directory, and then when the job is done, it moves it over. And that's how it makes sure everything is consistent. But you really don't want to do that on S3, so there's a series of direct output committers that you can use. Things are still not perfect. You can't use speculative execution, which seems like a nice feature, but we haven't been able to use it because it's incompatible with the direct output committers. And also, any failures during the write phase usually kill your job, and I think that's mostly because we're using this direct output committer. So if you have a failure, it retries and it finds that there's already a file there, and then you're done. Too bad. We got bit by a bug in 1.4.0. It randomly loses a small but significant percentage of your data. What happens is it makes up a file name based on the millisecond timestamp and tries to write to that file. If the file's already there, it gives up, and your data goes poof. So I prefer to stay away from the .0 releases if I can.
Or if you can try it on a different cluster that you will be running like simultaneously. Or something.
Yeah. Well, we didn't notice the bug. So I mean, we ran it for a few weeks in the production without noticing.
There was also a bug about Parquet, the filter pushdown.
Yeah, yeah. That one doesn't seem to be affecting us, but I don't know. Cool. We're pretty close. Mesos and Spark have two ways to go. You can use Coarsegrained mode or Finegrained mode. The upshot is you just want to use Coarsegrained mode. What happens in Coarsegrained mode is the driver asks the cluster manager, the Mesos, for some workers, and then Spark takes all of those workers and holds onto them for the whole job. So it's very stable, and your jobs generally finish pretty well. The downside is as you finish a stage, here I have only 5 active tasks running. You're holding on to whatever resources you had in the beginning, maybe 2,000 nodes of your cluster. So that's the downside. The upside is your jobs will actually finish without failing randomly.
It's an important thing, I think.
Yeah.
Did it happen that on purpose or because of a malfunction you reduced the cluster while Spark was running on it?
It's a little bit resilient to, we've lost nodes, usually when the spot instances are taken away. And it can handle a few, but if you lose more than, 10%, it'll usually crash.
It really depends on the amount of failures, I think.
Yeah, yeah.
Sometimes it doesn't fail, it just continues
pounding the resources, and that's it.
Yeah. The other way Mesos can run is in fine-grained mode, where there's an executor, and every time you want to run a job, you get kind of a sub-executor here. But these sub-executors are actually just different threads in the main executor, so they don't have any memory isolation. And what happens is, if this task, which may not even be your task, it may not even belong to your job, if it out of memories, it can take the whole node down and take your job and other people's job down at the same time. So don't use fine-grained. From what I hear, they're actually going to remove it in Spark 2.0. So they have something good coming up, which is coarse-grained with dynamic allocation. So here, when you get to the position that you're only using 5 of your cores, Spark will kill them and give them back to the cluster so other people can use them. this should be perfect. So far it's not working great. But we have some jobs that work fine, but other jobs just consistently fail in this course. Okay. It's interesting. One interesting point is that to do the dynamic allocation, you have to run an external shuffle service because your executor potentially won't be running after the shuffle, because it could have been killed off and maybe now you have fewer partitions and you don't even launch a new one. Okay. So you run an external shuffle service, but we've seen errors where you can't reach the external shuffle service, and we've also seen errors that you can't fetch the files after the shuffle. Not all the time, but on some of our big jobs it's not working yet. I'll just briefly say, if you have a choice, get fewer big machines rather than many small machines. This is a cluster of Raspberry Pis. Not a good choice for running Spark. So how do you control how do you get around an out of memory error? What you do is you first set the executor memory to be the entire memory of the machine. Remember, in course mode, you're taking control of a whole machine anyway, so you might as well take all the memory. And then use this setting, Spark task CPUs, which sounds like it wouldn't have anything to do with memory, but actually this is the way to set the memory. And you can see that here. If I set Spark task CPUs to be 32, on a 32-core machine, then I would get all 200 gigabytes for each task. So, and that's working pretty well. The other way to go is just add more shuffle partitions. Okay.
How do you determine the amount of partitions?
Trial and error, basically. If it's failing without a memory, try more. If it still fails, try even more, or it's hard. It's I don't have a great answer there. But more is usually better. Theoretically, if you have enough shuffle partitions, you should be able to run the job, as long as you have enough disk space to keep the shuffle, you should be able to run the job on one node. But in practice, not always. And this is my last slide. So I hope they increase the stability of the dynamic allocation. And another feature that I didn't talk about, the tungsten, is also only somewhat stable. This is in Spark. On the Mesos side, there's something really cool that they just released called maintenance primitives. And this allows you to, they have a notion of inverse offers. So normally the Mesos cluster offers you resources, but now it has the capability to ask you for the resources back. And this could now allow you to do things like mark that you're going to kill some nodes. You say, okay, I'm ready to bring my cluster down a little, and I don't want anybody to do work on these nodes, and now that's possible. And also, we could have true preemptive scheduling. So if somebody's using the whole cluster and they're willing to give it up, then you could launch a new job and take resources back from them, even if they're in mid stage. So hopefully those things will really improve our lives on Mesos. And finally, we're hiring, and it's a great place to work. I've been there about a year now, and it's been really fun. So, and thank you. So we have a couple of minutes for questions, and I'd love to hear what.
Can you talk about auto-scaling and spot instances?
Yeah.
And Mesos, of course.
Yeah, so you're asking about auto-scaling in Mesos. Ori, who's here, is working on a new system to launch the instances into the cluster. So as I mentioned, once you launch an instance, it automatically joins the cluster. So increasing the size of the cluster is trivial. Reducing the size of the cluster is a little tricky. You're welcome to just kill the machines, but maybe they're doing work, and that's where these new maintenance primitives come in. So they would allow you to notify the Mesos cluster itself. Oh, I really want to take these 5 machines down. Can you make sure nobody does any work, and anybody who's doing work finishes up what they're doing? So I think that's going to improve the scaling down part. Is that about your question?
Yes, but I was hoping to hear more about scheduling the jobs, the number of jobs, and how you bring up more spot instances based on that.
Yeah. So I wrote the scripts that just use the standard API calls to Amazon to launch the spot instances. And when we need more, we just say, give me 50 more, this instance type, this availability zone, and then they spin up and join the cluster. But we don't have anything automated right now. That's what Ori's working on. Because we'd like to tune how many nodes we're running over the course of the day. Anyone else?
Can you talk a bit about the performance when you write Parquet files to F3, the number of files, the size of the files, how did you manage to, for example, if the number of files is important for the performance, do you have another job that is consolidating files?
We don't have anybody consolidating files. We usually, if we need to consolidate, we'll call a coalesce before we do an output. So maybe we started with 10,000 files and we'll coalesce down to 2,000 if it's appropriate in terms of keeping the file size pretty large.
But you rewrite all your files the next day? Once you have some files there, you have let's say 1,000 Parquet files in F3. Then you have new data.
So we do it day by day, and the data all lives in folders that have the date. So we just start a new date each day, and we write in the file name, we write dt equals something, and that actually allows you to filter in Spark SQL. It'll create a virtual column called dt based on the actual the naming of the files, which is convenient.
Okay.
Yeah.
טוב, אז זו הייתה ההרצאה הראשונה, הסשן הראשון. קחו איזה 5-7 דקות הפסקה ככה להתרענן, ונחזור להרצאה השנייה עם איתי.